66 million years ago, a 15-kilometer-wide asteroid slammed into Earth at 20 times the speed of a rifle bullet. In an instant, the shockwave vaporized the crust, and the environmental context that favored sheer mass and strength disappeared. The impact injected 15 trillion tons of dust and sulfur into the stratosphere. This dense veil wrapped around the globe, blocking out the sun and dragging the planet into a sudden deep freeze. Across the world, photosynthesis nearly stopped, severing entire food chains at the roots. For tens of millions of years, the immense size of the dinosaurs gave them an unbreakable grip on the food web. But in a dark world suddenly devoid of plant life and thermal energy, that extreme mass became a fatal burden. The largest species, requiring the most daily calories, starved the fastest. The Chicxulub impact wiped out 3/4 of all species. It cleared the board entirely, resetting the biological requirements for staying alive on Earth. When we look at the rock layers from immediately after the catastrophe, we don't find the remains of giant trees or complex plants. We find a sudden, massive explosion of fern spores. Ferns reproduce without flowers or insect pollinators. They endure harsh conditions and spread rapidly, proving that simplicity was the most effective way to endure the immediate aftermath. In this period, small and flexible were the traits that mattered. The few mammals and primitive birds that survived the darkness shared specific features. They had low baseline energy demands, they could shift their diets to eat whatever was available, and many could hibernate, slowing their metabolisms to wait out the freezing years. The creatures that began rebuilding the planet's ecosystems were the size of modern mice. Earth's new biological foundation was laid by the most unremarkable animals, simply because they could tolerate extreme deprivation. 10 million years later, a planet stabilized, and then it swung violently in the opposite direction. Around 56 million years ago, immense geological activity injected thousands of gigatons of carbon into the atmosphere, triggering a planetary fever known as the Paleocene-Eocene Thermal Maximum. The Earth transformed into a planetary greenhouse. Average global temperatures soared by up to 8 degrees Celsius. Tropical broadleaf forests expanded all the way into the high latitudes, and the deep oceans lost nearly all of their cooling polar ice. With the environment overflowing with heat and energy, the ecological niches left empty by the dinosaurs finally filled. When resources are this abundant, mass again becomes a distinct advantage. Mammals expanded their body size by dozens of times, capitalizing on the lush vegetation to evolve into massive herbivores and multi-ton predators. This image shows a fossilized tooth from the ancient shark Megalodon, sitting behind the tooth of a modern great white. Megalodon grew up to 20 meters long, wielding a bite force capable of crushing a whale skull. In an oxygen-poor, nutrient-rich ocean, evolution rapidly scales up body mass to capture maximum energy. Back on land, South America's sweltering rainforests produce Titanoboa, a snake stretching 14 meters long and weighing over a ton. Because snakes are cold-blooded, Titanoboa could only reach this colossal scale on an overheated planet that pushed reptilian physiology to its absolute physical limits. The Paleogene era proved that when an environment provides limitless heat and resources, evolution often pushes physical size to its absolute extreme to dominate the food chain. Building a massive, highly specialized body requires a permanently stable environment. The moment those conditions falter, that extreme mass becomes a lethal trap. As tectonic plates collided, the uplift of the Himalayas physically altered the atmosphere. The sheer geographic mass of these new mountains disrupted global air circulation, pulling carbon out of the air, triggering massive monsoon systems, and pushing the entire planet into a deep cooling phase. By about 2.6 million years ago, the Pleistocene Ice Age arrived. Permanent ice caps clamped down on the poles, locking up the oceans and replacing the lush, endless tropical forests with expanding, freezing grasslands. The limitless resource base evaporated. Stripped of their endless food supply, the multi-ton creatures engineered for the greenhouse world starved. Their heavy armor and immense metabolisms could not pivot to the cold, proving that committing to a highly specialized biological design is a massive liability on a volatile planet. As the Ice Age intensified and the African continent dried into harsh savannas, early hominids were forced out of the shrinking tree canopies and onto the open ground. Looking at these ancient hominin remains, their physical vulnerability is obvious. Weighing barely 40 kilograms and standing less than 1.5 meters tall, they had no armored plates, no sharp claws, and no long fangs. They were slow, soft, and entirely exposed. Fossil evidence confirms they were frequently hunted. Early humans were scavengers, gathering leftovers on the margins, regularly eaten by saber-toothed cats, prehistoric hyenas, and giant eagles. Their primary defense mechanism was simply hiding. Under the old requirements of mass and strength, these early hominids were completely unequipped to survive. By all prehistoric logic, they should have vanished within a few million years. While the line representing hominid body size remains almost totally flat over millions of years, the line for cranial capacity takes an exponential upward curve. As the environment became unstable, survival shifted toward mental flexibility. A larger brain required enormous calories, but it provided advanced spatial memory and the capacity to learn from failure in real time. Instead of waiting hundreds of thousands of years for a genetic mutation to provide thicker fur or sharper claws, hominids at exactly this point began solving problems within a single generation. These are Oldowan stoneflakes. They represent a shift toward using technology to extend biological limits, allowing hominids to process meat and bone without the specialized teeth of a carnivore. Finally, stable control of fire drove predators away and made more energy available through cooked food. Social language followed, allowing tribes to coordinate complex strategies and pass critical survival data from one generation to the next, as the ice ages violently advanced and retreated. We did not inherit the Earth by growing larger or stronger than its prehistoric monsters. We survived because we embody the ultimate evolutionary lesson. On a planet defined by constant, merciless change, adaptability is the only permanent requirement for survival.